start, right? So how do we do the generation of reaction, generation of reducible representation and its systematic reduction in terms of irreducible representation, right? Okay, so if you recall a little bit, I think generation of reducible representation depends on the choice of basis, right? So that means what we are going to address the problem depending on that. So it is going to be the basis, and based on that, we will be generating the reducible representation. I mean, like I discussed in the class also that, like, suppose if I want to do the vibrational analysis, so that means the activity of the vibrational states, vibrational modes, then what choice would be like either Cartesian coordinates or the bond coordinates, right? So in that case, like what we have to do is that here actually I'm going to have two choices. Like if I am going to go for the symmetry of the normal modes, right? So let's now first choices is the, of course, the Cartesian coordinates. That is because, like if we have if we want to go for the vibration, like we can assign the Cartesian coordinates to oxygen, Cartesian coordinate to this hydrogen and this hydrogen also, and then finally we can do this using this assigning this Cartesian coordinates. Like this oxygen is the number 1, where I'm having Z, and then Z1, X1, and Y1. Similarly, this hydrogen, which is number 2, I'm having X2, Y2, and Z2, right? Like this, this hydrogen having also these 3. The second choice is, of course, I can go for the internal coordinates, like oxygen atom connected with the H1 with the distance bond distance R1, and then H2 connected with the oxygen with the R2, and the angle between R1 and R2 is going to be basically the alpha, right? So that is going to be the bond angles, and using this we can generate the reducible representation, right? So let's start with the first one, both having advantages, disadvantages, but let's go for the first one and see how we can do it. Okay, here we go. So this is the structure of what we have seen on the last slide. So all the atoms are having independent Cartesian coordinates, right? Now we can do in 2 ways, and then I'll show how they are going to go parallel with each other. Right. Let's first go with the vector unsifted rules. What I think I have already discussed in that class. Basic way. This very simple way to tell it that if like take any vector, if the vector is unsifted, then the character contribution will be +1. Right? And if the vector shifted means it changes its location, then character contribution will be 0. And if the vector unshifted but change the direction in the reverse, then it is going to be -1, right? So like that we are going to use that. Now let's come here. That is the basically the representation, reducible representation based on x, y, z, and the way I'm going to do it, like how this x, y, z Cartesian coordinates are going to change for each of the atoms, right? Okay, so now let's go for identity operation. Now, when you do the identity operation, how many Cartesian coordinates I am having? 3 from oxygen, right? Z1, then X1 and Y1, and then for hydrogen I am having X2, Z2 and Y2. Similarly, for the second hydrogen, like I am having Z3, X3 and Y3. So like this we are going to use. Now let's, if I do the identity operation, so that means I am not doing anything, right? So that means all the Cartesian coordinates remains in the same place, so neither changing the direction nor changing the position. So the contribution for like Z1 will be +1, for Z2 Z1 will be +1, then X1 will be +1, and then Y1 will be +1, right? So like that. So this is going to be my 1, then this is going to be 1, this is going to be 1. So that is going to be +3. Similarly for this is going to be 1, for Z21, X21 and Y2 is going to be 1. Again for Z31, X31 and Y3 is going to be 1. So total how much I get? That is basically 9, because if we add it up, so that is going to be 9 out of 9 vectors, right? So total is going to be 9. Of course, if you are going to think that this is going to be a 9-dimensional problem, so that's why this identity character under identity for the reducible representation is going to be 9. Okay. Now, if you go for C2, which is along Z, so that means it goes like along this, right? Then if I perform C2, what happens? How these vectors are going to change? Now, look at here for this H2. So if I perform C2 either clockwise or anti-clockwise, then this H2 is going to go there, and then this H3 is going to come here. So what does that mean is that all the Cartesian coordinates associated with this H2 is going to move to this place. Again, this all the Cartesian coordinates associated with this is going to move to the this place. So that means they are changing, so their contribution is going to be 0, right? But for this oxygen atoms, if we look at carefully, if we do the C2 along Z, so then look at here, Z remains unchanged, right? So for that, this is going to be 1, right? And for Y, this is going to be go to a -1, so because that is going to change the direction. So let me change these values, and then I should be able to calculate what is the exact value, right? Right. Yes. So Z remains Z1 remains unchanged, so character is going to be 1, and if I do C2, this X1 goes to -X1, so therefore this is going to contribute basically -1, right? So for C2 rotation, this is going to be -1. Then Y1 again going to go to -Y1. So contribution for this is going to be -1, right? and rest of them are going to be 0 because this is going to be shifting, this is going to be shifting, so this is going to be 0, this is 0, right, and this is going to be 0. All are going to be, rest of them are going to be 0, right? So therefore, what is the value I'm going to get if I sum them up? So I get total is -1. So character under C2 for the reducible representation based on x, y, z, I'm going to get -1. Okay, I hope that is fine with you. Yeah. Now, if I go for sigma v, right? So sigma v is kind of similar to your C2, but there is a little bit different. So let me again remove this, and then I should be able to tell you how these are going to be contributing, right? Okay, so now if I go for sigma vxz, right? So that is basically this plane, right? So sigma vxz means this plane. Then only this x1 and z1, they remain on the plane, right? Rest of them are going to interchange because this is going to be reflected here, this is going to be reflected there, so they are all going to change. So I'm just collectively putting them 0 for this contribution, 0 for this contribution, right, for these two atoms. But when I go for this oxygen, then what happens? Now this xz plane contains the x1 and z1, right? So therefore, z1 is going to be 1, x1 is going to contribute 1, but this y is going to, y1 is going to go to the minus y1, so therefore contribution is going to be -1, right? So therefore, the total sum is going to be 1, right? So that number comes here, right? Okay, now go for the sigma v prime, is yz plane, right? So now in that case, again I have to go for, so that plane is nothing but this molecular plane or the plane of the this computer. So how that is going to be contributed? Okay, so let's remove this first, and then I can come back to this. Okay, so yz plane means this is the plane of the computer screen. So therefore, that is going to be z1, y1 will be on the plane, z2, y2 will be on the plane, z3 and y3 will be on the plane, but x1 will go to minus x1, x2 will go to minus x2, and x3 will go to minus x3. Okay, so systematically add this number. So z1 remains unchanged, plus that is 1. Then y1 remains on the plane, so that is 1. But x1 is going to go to minus x1, so that is going to be -1, right? Exactly in the same fashion, it is going to go for H2 also, right? Z1 is going to be, sorry, Z2 is going to be 1, Y2 is going to be contributing 1, and X2 is going to be -1, right? So now in the same fashion, like here, Z3 is going to be 1, and then Y3 is going to be 1, and x3 is going to contribute -1. So it's like that, and then so what is going to be the then total number? Total number, if you look at here, that is going to be like 1 plus 1, 2 minus 1. So that contribution comes from here 1. Exactly same as this is contribution will come from 1. So 1 plus 1, 2, and from there you are going to get 1. Right. So therefore, total sum is going to be 3. So the character is going to be 3 there. Right. I hope you are with me. and then I'm proceeding with. So if you have any problem, then we can discuss at the end of the towards the end of this discussion, right? So the what basically we generated is that the Cartesian coordinates are assigned to all of the atoms, individually atoms, and then I'm going to generate a reducible representation. And as I am having 9 Cartesian coordinates, because I am having 3 atoms, 3 into 3, 9 Cartesian coordinates. So therefore, it is a 9-dimensional problem, and therefore the reducible representation of what I get under the identity, that should be 9, right? Okay, so that is the reducible representation. Now we can do it in a different way, in a simplified way, like how we do it is a number of unshifted atoms way, right? So that may be a little bit much more easier to do that, right? So let's do it, right? So a lot of people are waiting. I do not know. Yeah. So let's come back. Like number of this n stands for number NUSA, number of unshifted atoms, and then this is the character for the corresponding operation under the per unshifted atoms, right? So that's what I am going to do it, right? Okay. So now if I perform the identity operation, then what is going to be the number of unshifted atoms? Okay, let me remove these numbers. That will clear it up. Yeah. So now if I go for identity, right, for this, now how many number of atoms are going to be unshifted? So that is basically 3, right? Because oxygen is going to be unshifted, this hydrogen is going to be unshifted, this hydrogen is going to be unshifted, right? So I'm going to get for under identity number of unshifted atom is going to be 3, right? Now if I do C2, right, C2 along Z, right, this is the Z axis. So if I do either clockwise or anti-clockwise, it doesn't matter. If I do C2, oxygen remains unshifted, right? This H2 goes there, this H3, that means number 3 atoms, like it comes here. So therefore only oxygen remains unshifted, but these 2 hydrogen shifting, right? Okay. Yeah, Vinay, tell me. Abhinay? Okay, I think I could not connect him. Anyway, so maybe we can discuss later on. Yeah. Okay, so let's come back. So when you do C2 along Z, right? So then these 2 hydrogens are going to be shifting the position. Only oxygen remains in the same place. So therefore, number of unshifted atoms, if I count for C2, is going to be 1, right? Now, if I go for sigma V xz, so that is this. Uh, uh, please unmount because I'm getting some voice, so that might be recording. Yeah, for sigma V xz. So if I do xz, like this, then these two atoms like H2 and H3, that is going to be shifting, and O1 is going to be unshifted, right? So therefore this is also going to be 1. Now if I do a sigma v prime, that is yz, so that means that is the plane of the computer or the plane of this paper, like if you think about, so then all of them are going to be unshifted, right? So therefore the number of unshifted is going to be 3 there. Okay, now we count the number of unshifted atoms. Now if we can add the characters for each atom, character contributions for each unshifted atoms, and then multiply, we should be getting the total, right? Now if I go for the Cartesian coordinates, and if I go for the identity operation, if you remember this the character how we get is nothing but the summation of the diagonal elements of the matrix. So that is 1 0 0 0 1 0, right? And then I'm going to have 0 0 1, right? So the character is going to be 3. So that is I think you all remember this. So that character is going to be 3, right? So now if we go for this C2, then it is going to be like how do we again, if we generate the C2 of this matrix, so that is going to be giving you the what is going to be the character. I'm not going to repeat this, so I hope you will remember this is for C2 is going to be -1, because this is going to be twice cos theta plus 1. So if we go for twice cos 180, right? So that is going to be -1, right? So that is going to be -1. Now sigma v, of course you are going to get 1, right? And then sigma b prime also exactly you are going to get 1, right? So that is the character for each of the unshifted atoms we get, right? Now if we get the total number, then what we have to do is basically we have to multiply the I'll just remove this and then I'm coming back. So now if I want to get total, then I have to multiply this 3 into 3. So if I multiply this, then I'm going to get 9. Again 1 into 1 -1. So that is going to be -1. And then this is going to be again 1 into 1. This is 1. And then again this is going to be 3 into 1 is going to be 3, right? So that is the total representation we got, reducible representation. So now this we have verified using the method, which is a shortcut method, which is nothing but is the number of unshifted atoms multiplied with the character per unshifted atom, we get the total. And this we got directly using this vector unshifted rule. So they are matching. So I think we have done right thing to do it, right? Okay. Now once we have this, now what is this? This is nothing but the total representation for the translation, rotation, and vibration. And our target is to find out what is going to be the symmetry of the vibration, right? Why it is translation, rotation, vibration? Because using the Cartesian coordinate, we can discuss the translation motion and rotation motion, and also the vibration motion, right? So that's why it includes. Now let's go to the next page, and we should be able to do it, right? Now this can be reduced using the reduction formula, right? And that formula is basically goes this way. Let me explain this, then we are going to do it. So it's the number of times the ith irreducible representation going to occurs uh, in the total representation, right? So here it is, the n is the number, I stands for the ith irreducible. Ith means if I go for C2B, then it can be A1, A2, B1, and B2, any one of them, right? And is equal to 1 by order of the group, H, order of the group. That order is nothing but the total number of non-redundant operations. So for C2V, it is going to be 4, that is identity C2, sigma V and sigma V prime, right? Okay, now we have to do sum over all the operation. So I'm doing for all the operation, not over the class. Just for the timing, stick to this. Sum over all the operations, and then this character is for the reducible representation, what we get using the XYZ, right? Corresponding to each operation. Now, this character is the character corresponding to the one I am going to generate the number. So that is irreducible representation, right? And that irreducible representation can be either A1, A2, B1, or B2 corresponding to this operation, right? Okay, so let me explain this, then I think you will be getting better. So what I mean is that if this is having the total number of uh, representation, so the total number of reducible, and then how many A1 are going to be coming in that, then how many A2 is going to be coming in this representation, how many B1 and how many B2 are going to be that, right? So that means if I take the character tables, I want to know if this is going to be the total representation, how many A1 is going to be appear in this, how many A2 is going to be appearing in this, and how many B1 and how many B2 are going to be appearing in this representation, right? So let's do it, work it out. I think we are running out of time, so we have to do a little bit quick. So now, yeah, so I'm going to go for the first A1, right? So this is the reducible representation. Now this is A1. I want to find out how many A1 I'm going to get it, right? So for that, what we have to do first, take the character of reducible representation, that is 9, and then the character of irreducible representation, that is 1, multiply that. So I'm doing only this part, right? So that is this one. Okay, then for C2 operation, I have reducible representation -1. Then for irreducible representation A1, it is going to be 1. So I multiply -1 into 1, right? Then exactly in the same fashion, this is 1 into 1, and this is 3 into 1, right? Now what I need to do, I need to sum them up over this. So let's write that. So I want to find out NA1, right? That is going to be equal to 1 by order of the group. So that is 4, right? Then I'm going to have the, for identity operation, I'm going to have 9 into 1, right? That is 9 into 1 plus, for C2 operation, I'm going to have -1 into 1. So that is -1 into 1 plus, for sigma V, this is going to be 1 into 1 plus, for sigma V prime, this is going to be 3 into 1, right? So that is going to be, how much is going to be? I think you can calculate that. So if I just look at here, this is going to be cancelling out, right? Then I'm going to have 9 plus 3, that is going to be 12. So I'm going to have 1 by 4 and multiplied with the 12, right? So that is nothing but is going to be 3, right? Okay, so that means what I get is they telling that in this reducible representation, I am having 3 A1 appearing in that, right? So now if I do this in exactly in the same fashion, right? So then I'm going to go for N2, sorry, A2. In A2 is going to be 1. It's exactly if you do calculate like this, then NB1 is going to be equal to 2, and then NB2 is going to be 3, right? So that means the total number what we get exactly is going to be something like this representation. So that is basically what I got is like 3A1 plus 1A2 plus 2B1 plus 3B2, right? So this total number all includes basically translation, rotation, and vibrations, right? Now, if I remove this translation and rotation from this total number, if we subtract this, I should be getting vibration, right? So now how I am doing this? So I look at the character table. If you look at it, this translation is basically transform like how X, Y, Z goes. Like, so Z is A1, X is B1, Y is B2, right? So therefore, translation transform as A1, B1 plus B2, right? A1 plus B1 plus B2. Now, if we go for rotation, right, rotation is going along RZ, RY, and RX. So RZ is going to be A2, RY is going to be B1, RX is going to be B2, right? So that is A2 plus B1 plus B2, right? So now, if we subtract these two from the total, then I'm going to get the vibration, right? So, Sugat, I think I'm going to running out of time. Should I stop here? Okay, so that gives you the total vibrations are going to be, 2 of them are going to be A1 and 1 of them are going to be B2 symmetry. Look at it, that's what we try to do it, the symmetry of the normal modes of water. So normal modes are, we know that that is going to be 3 of them, 3 into 3 minus 6, so that is 9 minus 6, 3. So that is going to be this 3. So I think we are with the numbers what we are going to be expecting, right? So I think I should stop sharing now and see what is the time we have done it, right?